Today, I'm going to teach you about factoring quadratic expressions, and that starts now. Hello, ladies and gentlemen, and welcome back. Glad you could make it. Welcome back to our channel, where I'm Mr. Thompson, and it's our job here to show you that bow ties are cool and math is fun. Today we're going to look at factoring quadratic expressions, and we're going to use the factoring of the quadratic expressions to find the zeros of zeros of a quadratic function. When we're talking about zeros, a couple of things we have to keep in mind. First, the zeros of the function. Roots, solutions, zeros all mean the same thing. Roots, solutions, and zeros all mean the same thing. Parent function, y equals x squared. There's one zero, there's one solution. So you see there's one place where this thing touches the x-axis. Where it crosses or touches the x-axis, that's going to be considered our zero or our solution. Going on to the next one, look at the red function, y equals 3x squared plus 6x minus 3. So look at that function, that one also only has one zero. But in this case, instead of sitting on the x-axis, it's actually hanging from, because that a term is negative, so that's reflected. So it's got one zero hanging from the x-axis. Looking at our third function, y equals x squared minus x minus 2. You'll see that this one actually has two zeros. This has two places where it's crossing the x-axis, so it has two solutions or two zeros. And then our purple function up here, 1/2 x squared plus 2, notice that that does not touch the x-axis, so it has no real zeros. It has solutions or roots. They're imaginary, and we're going to get to that in a later video. Ladies and gentlemen, the next thing we're looking at is the zero product property. The zero product property says if the product of two quantities is zero, at least one of those quantities has to be zero. In the case of like 5 times 0 equals 5, we have one quantity that's zero. A, B equals 0. That means either A has to be 0 or B has to be 0. We're going to use the zero product property to find the zeros or the solutions. In this case, x times x minus 6 equals 0. That expression is already set equal to 0. So what we're going to do is set each piece equal to 0. An x equals 0 and an x plus 6 equals 0. X equals 0 is already done. X plus 6 equals 0. We need to go and move the 6 to the other side. Solve that out. We get zeros at 0 and negative 6. And the last thing we're going to do down here is we're going to check it. Substitute both of our zeros back in. Make sure that it works. Factoring a quadratic expression. In this case, x squared plus 11x equals 0. We're going to do the factoring on this. And the first piece that we need to do for factoring is look for greatest common factors. Looking at what is a common factor in creating each of these two terms in our binomial. In x squared, you break that up to x times x. 11x is 11 times x. So I see that I've got an x and an x that are in common, so I can factor those out. I can pull them out as a group. And when I pull the two x's out, it actually becomes a single x out on the outside of the parentheses. We want that to be a single x because if you could imagine when we go to multiply those doing the distributive property, that x gets applied to everything inside the parentheses. So it has to be common as it comes out to the outside, and it just becomes one single x term. Go ahead and factor that out. We'll factor the x out. We're left with x times x plus 11 equals 0. And from there, we can establish our zeros at x and negative 11. Enough of the easy stuff. We're taking the training wheels off. We're heading for the double black diamond. None of this bunny slope stuff. We're going factoring now. We'll look at x squared plus 15x plus 36 equals 0. We're going to go ahead and factor this to find the zeros. So first thing we have to do is we've got to look at this thing. Okay, how is this compared to standard form? Ax squared plus bx plus c. Got to look and see what is a, what is b, and what is c. Once we've established those, then we can use a pattern that you're going to be so sick of hearing. Factors of AC that sum b. Factors of AC that sum b. So I'm going to multiply my a term times my c term. Factors of that add to b, that add to the center term. That's what we've got to find. So I'm going to do a little table, a little chart here. All right, AC that sum b, factors of 36. Go ahead and list all those guys there. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now, I notice that 36 is positive, and so is 15. So that means all my factors are positive, and I can add them all up, adding straight across, and I see here that 12 and 3 is going to be the factors that I'm going to be using. Now, here's where the factoring piece comes in, because I had a trinomial, 3 terms. But to find the zeros, I need 2 binomials. I need 2 linear expressions. So I'd like you to dig deep down into your soul, and I want you to find that very violent part of you. If you're a hockey player or a lacrosse player, that's easy, all right? Because what I'm going to do is I'm going to take this 15, and I am going to break it apart. You thought I was going to say something else, didn't you? I'm going to break this apart. I'm going to split it up into positive 3x and positive 12x. So would you agree that 3x plus 12x equals 15? Yes. So we're just writing it in a different way. Bring down the x squared, bring down the 36. Now the next step. This is where we do factor by grouping. Group of 2 in the front, group of 2 in the back. Okay, now I've got 2 binomials, but there's too many common factors in them. So what I'm going to do in this case, take the greatest common factor out of the first group. Factor the x out. And then this x plus 3, this becomes the driving force. This is like in the movies, you know those mean girls that all walk around dressed the same and carrying their little Starbucks and wearing the Ugg boots going, oh, look at me, look how pretty I am. Well, this x plus 3, this is the driving force. This is like the main mean girl, or the main, I call them the Starbucks girls. All right, that's the main Starbucks girl. They're the one that decides what everybody's going to wear. And then they send out the little text messages, and the next day everybody shows up all dressed the same. Well, this second binomial has got to look like that first one. So I got to look up here and say, all right, what in this binomial, what in this expression can I take out of here to make it look like x plus 3? Well, you're right, I'm going to take out a 12. Good. Now, those mean girls, those Starbucks girls, they all share a common brain cell. So they all think the same. So because they only have one brain cell, we're all going to do what's in common once. So we write what's in common once. And then this is like the meatloaf sandwich. This is the leftovers. This is the best part of the next day after turkey dinner, right? You bring all the leftovers together. You write what's in common once, and then the leftovers. We set that equal to 0. Now, we've got our binomial set equal to 0. We can go ahead and set each piece equal to 0 and solve for our zeros at -3 and 12. Factoring a quadratic function, we're looking at x. Unit x squared plus 4x minus 12. Once again, going with the ax squared plus bx plus c, figuring out what a, b, and c are. And in this case, a is 1, b is 4, c is -12. So that's going to change my factors of AC that sum b pattern. That's going to change that AC term into negative, which means my factors are going to have different signs, because I'm going to be multiplying to a negative. So I list my factors of 12 that are going to add to +4. So I look here, negative 12 to add to a positive 4. So that means my smaller term, or the term with the smaller value, is going to need to be negative. And now I add them across and I end up with negative 2 and 6. Do the same thing we did on the last one. Get a little aggressive, break this up. Factor by grouping. Do the little Starbucks girl routine. What's in common once, everything else that's left, and then finally our zeros. And finally our zeros. Setup on this one's a little bit different. X squared minus 3x equals 18. We need to apply the zero product property first and set this expression equal to 0. So I'm going to move the 18 to the other side. X squared minus 3x minus 18. A, B, and C. In this case, A is 1, B is negative 3, C is negative 18. So now I'm multiplying to a negative and adding to a negative. Going to once again have a different effect on my signs. In this case, the larger term is going to have, the term with the greatest value is going to have to be negative, so that I can multiply to a negative and add to a negative. Work through our table, figure out which one we need, bring it back into the expression, split up that B term into its two pieces, factor by grouping, pull out the common factor, find your Starbucks girl, make it match, factor out in this case, nope, I just lied to you. I'm here going through the whole thing and I didn't even look at my notes. I was going to show you a trick on this one. It's going to help you cheat. Don't tell your math teacher, but this is a trick. This works. Only on certain occasions does it work, though. There's a secret. If A is 1, what you find in your factors of AC that sum B T chart, those actually become the constants in your binomials. So you can just take them right out of the chart, boom, make two binomials out of it. This only works when A is 1. Only works when A is 1. Only when A is 1. Please, please, please don't try and do it every time. Only works when A is 1. But that works. In this case, we set each piece equal to 0, and we've got our zeros. You didn't think I was only going to give you the easy ones today, did you? Yeah, we got to do some of the hard ones where A isn't 1, where that cute little trick that I just showed you doesn't work. So that's why I showed you all of the factoring all the way through. Now, here's why that was so important before. So 2x squared plus 5x minus 3. In this case, A is 2, B is 5, and C is negative 3. We do our factors of AC that sum B, we end up with negative 6 that adds to positive 5. So what's going to happen is we list our factors here, and we add them up. When I bring negative 1 and 6 up here in place of positive 5, bring it up here in place of positive 5, I split it up, and now I have to pull out the common factor just like I did before, do my factor by grouping. What is here? 2x squared minus 1x. I left that 1 there because it's 1 times x. When I factor the x out, that 1 still stands in place. A lot of times people will pull that x out and then they'll just write it as 2x. And then when they go to check it by doing FOIL, it doesn't work. So make sure you leave that 1 there as your placeholder. Make a match, pull out the common factor, and then we're going to go ahead and set each piece equal to 0. And we have our zeros coming in at 1/2 and negative 3. A isn't 1 anymore, is it? Are you scared? Don't be. I'm going to show you how to fix this. Factors of AC that sum B. So factors of 2 times 6 that add to 7. We do our T-chart. We go ahead, we figure out which one of our factors we're going to be using. In this case, we're going to go with 3 and 4. Bring that up here in place of 7. Substitute it in, split it up. Factor by grouping. factor all these guys out. What's in common once? Everything else. Set it equal to 0. And then we can find our solutions, find our zeros. And yes, we can have solutions that are fractions. 4x squared minus 9x plus 2 equals 0. A is 4, B is negative 9, C is 2. Factors of AC that sum B. Notice in this case, AC is positive and B is negative. The only way I'm going to multiply to a positive and add to a negative is if both terms are negative. So I make all of my factors negative. Work through the chart, figure out that it's going to be 1 and 8. Bring it up, substitute it back in. Go ahead and work through our factor by grouping. Pull out the greatest common factor, x in the first group. Pull out the greatest common factor in the second group, our negative 2. What's in common once? Everything else that's left. And then we can solve for our zeros. Last example for you for today, ladies and gentlemen. This is a 2-for-1 deal. I'm going to show you 2 different things in one problem. 3x squared minus 18x equals 27. Just like in an earlier example, we have to move the 27 to the other side. When I subtract 27 from both sides and move it over, I end up with negative 3x squared minus 18x minus 27. Looking at all 3 of those terms, they've all got a common factor of negative 3. So I can go and pull that negative 3 out and actually make the problem easier to solve. So I'm going to factor the negative 3 out of each one of those pieces, and then this problem becomes super simple to factor. Factor this out. Now my A term is 1. The C term is 9. Factors of 9 that add to 6. 3 and 3. Still have to leave that negative 3 out on the outside. X plus 3 equals 0. Yeah, I've got factors that are both the same. This is a special case. We're going to do a whole video on special cases. But for this special case, we'll call this a perfect square trinomial. We'll go ahead and solve this. X plus 3 equals 0. So our final answer on this one. Notice how I set the negative 3 equal to 0. And then we go and cross it out. Because that was one of our factors. Yes, it was one of our factors in the original expression. Only a stretch factor. In this case, it's a reflection and a stretch factor. So it's going to flip that graph over and stretch it by a factor of 3. So it affected all 3 terms. But notice it didn't affect my 0. That 0 is still hanging right there on the x-axis. Our final answer, 1, 0 at negative 3. Ladies and gentlemen, this brings us to the end of our work today on factoring. We're going to have plenty more videos on factoring. We're going to do some special cases. I hope that this has helped you with your work with factoring. If it has, do me a favor, go ahead and smash that like button. Let the YouTube algorithm know that this is some good stuff. Hey, speaking of good stuff, if you want to see some more good stuff, subscribe to this station. Station. This isn't a station. This is a channel. Subscribe to this YouTube channel so that you can know when I make new math videos to help you with your math course. As always, ladies and gentlemen, I hope you have a fantastic rest of your day. I'll see you on the next one.